Okay, so now I'm going over question 26. So the important concept in question 26 is gravitational potential energy. So basically, well, first I'm going to write down the equation. So U is equal to negative G M over R. Okay, so G is the gravitational constant, and I believe it is 6.67 times 10 to the negative 11th, and R is the radius, and these two m's are the masses of the two objects. So basically what this says, well, okay, I'm going to draw a picture to show what it's kind of meaning. So let's say this is the Earth, and this is an object, and it is at a radius r away from the Earth. Basically, this says that as this object increases or gets farther and farther away from the Earth, the gravitational potential energy will increase, as shown by this principle. And as it gets closer, the gravitational potential energy will decrease. So it's similar to potential energy, but basically this is one mass, this is the other mass, this is the radius, and as the radius gets bigger, this will increase. So basically, that's just what it's saying. So now I will read question 26. If U1 is the potential energy of the planet satellite system containing the satellite of mass m1, and U2 is the potential energy of the planet satellite system containing the satellite mass m2, which of the following expressions best represents the ratio U1 divided by U2? Okay, so first I'm going to draw the picture just so it makes sense of what's happening here. So I'll erase this just to make more room. Okay, so basically in this question, this is the outer orbit, and it has mass m2 going v2, and then this is the inner orbit, and it has a mass m1 going at v1, and this is the planet inside. This is R1, R2. Okay, so basically it is asking for U1 divided by U2. So in order to do that, we need to find the potential energy of the inner orbit divided by the potential energy of the outer orbit. So first, for the potential energy of the inner orbit, we're going to use this equation. U1 is equal to negative G M, mass of the planet, M1, which is this, divided by R1. And then we're going to put, for U2, is going to be negative G M M2 over R2. And then it wants us to divide it, so we're going to divide it. So we're going to do negative GM1 over 1 divided by GMM2 over R2. And another way to do division is to multiply by the reciprocal. So we can do negative GMM1 over R1 times, flip it, R2 over negative GMM2. So we can do some canceling. We can cancel the negative GM's are the same, and then we can multiply out. So M1 times R2 over R1 times m2. And if we look at the answer choices, this perfectly fits answer choice C. So that means that the correct answer to this problem is answer choice C. So in conclusion, this video, or questions 26 in general, showed the important concept of gravitational potential energy and how as an object gets farther away from another object, the potential energy will increase, and when it gets closer, the potential energy will decrease. And using that equation, we were able to solve U1 over U2 in this orbital system.